Hello viewers, welcome to my channel. Today we shall be looking at the topic indices. Indices is regarded as the language of mathematics. It is regarded as the language of mathematics because most of the other concepts in mathematics require the application of indices and resolving one or two questions pertaining to that particular concept. So indices is required in resolving majority of the questions in mathematics, and that is why we say that indices is the language of mathematics. By the end of this video, you should be able to understand the various laws of indices with these various examples. Let's start with number one question. In number one, we have 5y multiplied by 4y raised to power 4. This is regarded as the multiplication law of indices. And what does that law say? The law says that if you have, for example, m raised to power a multiplied by m raised to power b, when you have an indices whereby they have common base, in this case now, common base of m, and they have some powers here, the law says that if you are dealing with multiplication, you choose one out of the two common bases, that is m, and add their powers. That will now be a plus b. That when you are talking about indices of a common base, you add their powers if you are talking about multiplication. And that is exactly what we'll be doing here. When you look at the question, we have 5y multiplied by 4y raised to power 4. Of course, 5 and 4 are not similar, but they have something in common, which is what? Y. So look at how we're going to resolve this particular example. So what we're going to be doing here is to multiply out the ones that are not common. That is 5 and 4. 5 multiplied by 4 will give us 20. 20. So they have y in common. Recall what we just did in the law that we just propounded here. That is the multiplication law. So we are to add their powers because we are dealing with multiplication. So this y has an invisible 1 on it. Whenever you have an alphabet, let's say m, without any number on top of it, there is assumed to be 1 on top of that. So an invisible 1 there. All right, so to resolve this, that will now be 1 plus 4. All right, so to go further, that will now give us 20y raised to power 1 plus 4 will give us 5. So this becomes the solution to number one question. I hope this is quite clear. All right, so let's take number two. Number two is the division law of indices. Number two is division law, where we have x to the power 3 divided by x to the power minus 5. So what do we do in this instance? The law says when you are dealing with division law, if you are dealing with division law, all you need to do, as we have it here, m raised to power a divided by m raised to power b. The law says that when you are dealing with division law of indices of a common base, you choose one of the bases, which is m in this case. Then since we are dealing with division, all we need to do is to subtract their powers. So therefore, when you are discussing division, you subtract their powers. When you are talking about multiplication, you add their powers. So we are going to be doing a minus b. That's exactly what we're going to do in this particular question. Now let's take a look at the solution, how it will look. So in this very instance, we are going to be saying they have common base of x. So we say x to the power 3. Then because we're dealing with division, we have to subtract. That's minus what? Minus 5. So what do we do? The next step will now be x to the power 3 minus multiply minus will give us plus 5. So the final answer, the final solution to this will now be x to the power 8. That is the solution for the number 2. I hope this is quite clear. All right, so let's take number 3 example. Number 3 says 4 raised to power minus 3. This is what we call the negative power law of indices. Look at what the law says. If you have, for example, m raised to power minus a, for example, the law says that this minus here as a power represents inverse. It represents inverse. And that inverse is in the form 1 over. So this minus here represents 1 over, which is what? The inverse. Then once we use 1 over to represent this minus, the remaining thing will now be m to the power a. So this and this particular one are the same. So that's exactly what we're going to do to this particular example. So we are going to apply it here. So what do we do next? For this minus means 1 over, then 4 to the power 3. So that's what we have there. So what we do next is to simplify further. And to simplify further, what we are going to be having will now be 1 over 4 multiplied by 4 multiplied by 4. And the final answer here will be 1. 4 times 4 will give us 16. 16 times 4 will give us 64. So the answer to this will be 1 over 64. That is for number 3 example. Now let's take number 4. Number 4 example is the product power law, of which in this instance, whatever you have as a power outside of the bracket affects everything, all the powers of what you have inside the bracket. So this 3 here affects 5, this 3 here affects m, this 3 here affects n raised to power 3. Take for example, if you have it as m, n, for example, let's say m to the power a, all to the power b. The law says that whenever you have a certain power within the bracket and the power outside the bracket, those two powers will multiply each other. So you now have it as m raised to power a multiplied by b, which will eventually give us m to the power ab. So that is to say, this 3, whatever you have inside, if you have it as, for example, you have it as x, y, let's say you have a here, you have b here, then all to the power c. Okay, so that is to say this c that you have here as a power affects everything you have inside here. To open this bracket will not mean that you have your x, which is already to the power a, multiplied by the one that is common to them, that's c, then y to the power b, then multiply to the one that is common to both of them. So the power you have outside of the bracket affects all the entities, the power that you have inside. So in this instance, we have it as x raised to power ac, y to the power b, c in this instance. That's exactly what we're going to do here. That's the product power law of indices. Now I'll show you how the solution of this particular one will look like. All right, so the next step we are going to take is to open the bracket. Opening the bracket, just record what I just said now, that this power here affects everything here. So that will now be 5 to the power 3. Okay, it affects everything. This 3 here affects every item you have inside the bracket. M, then power 3, then n is already to the power 3 here, then multiply to the one that is already outside affecting all of them. So the final solution to this will now be 5 to the power 3 will give us 125, which means 5 times 5 times 5, that will give us 125. Then m to the power 3, n to the power 9. That's 3 multiplied by 3. And this is the solution to this particular example. Now let's move to number 5. I hope you are getting this. So please don't forget to click on the subscribe button so that you'll be able to get other subsequent videos on the indicia equations, which will lead us to logarithm. Please don't forget to share the video with your friends because mathematics is very interesting. Share this idea, share this interesting video with them so that they'll be able to enjoy mathematics. Now, number 5. Then number 5 is known as the root law of indices. This is what we call the root law. The law says when you have a particular variable raised to power of a fraction, let's say a over b, whenever a certain entity is raised to power of a fraction, in that fraction that is a power, the numerator part of the fraction represents power, while the denominator part of the fraction represents root. If, for example, you have it as m to the power 1 over 2, this is root law, whereby the number we have on the denominator represents root. In this case now, if you have 2, you call it the square root. If it's 2 you have on denominator as a root, you call it what? Square root. So it's going to look like this, of which this one is powerless. If I say to the power 1, you still give me something. So if you have it as m to the power 1 over 3, So the one you have at denominator tells us the root. When you have it as 3, it represents the cube root. And this is how it will continue to flow in that order. If you have it as 1/4, then we are talking about the fourth root of m. So this is exactly how to represent this, because this will be helping us in resolving the question here and this one as well. Now let's take a look at the solution to the one we have on the board. I believe you can predict what the answer is. Then for this, how do we represent something of this nature? If we have the question written in this form, assuming what you have on the denominator, the numerator is not 1, that is a valuable number there. So what we will now have will be root b of m all to the power, because we say this one represents power a. That is exactly how we represent this. Now, going forward, let's apply this in this our number 5 example. So to solve this, you can predict what this one represents. Of course, the root we are talking about here is cube root. So it's gonna look like this, the cube root of 8. If we say to the power of 1, will still give us something. So in this case, the answer here will be, it's just like saying, what number do you multiply to itself 3 times to be able to give us 8? And that number is 2, because if I say 2 multiplied by 2 multiplied by 2, so 2 times 2 times 2 will give us 8. So the cube root of 8 is 2, and that is the answer to this particular question. I hope this is quite clear. For example, somebody gives you a question like this. Once you know what the denominator of the fraction, that is the power, is, you should be able to know the root in question. So this one is called square root of 9. Of course, the answer to this particular one will be what? 3. All right, so let's take number 6 example. Number 2 represents negative power law, just like number 3. So how do we approach this? Some students, just like what we did here, that when you have a 4 to the power minus 3, that this minus means 1 over, then 4 to the power 3, that these two things means the same. Some students will use that same idea in this particular example, and they will write it in this form. Since this minus means 1 over, they will now write the remaining part of it, which is 2 over 3. You see some students writing the question like this, the solution like this. That is not wrong, but sometimes it do confuse some students, of which you can reinterpret this to mean 1 divided by 2 over 3. And when you do that, you have to transform this in the form of what? Multiplication. And when that is done, this one will go up, then the 2 will come down. And you now have it as 1 times 3 over 2 will give us 3 over 2. And that is the answer to this particular question. So students do approach this question like this. But there is a simple way of doing this rather than arranging it in this form. So, and that particular idea I want to share with you is that this minus as a power here means inverse. If you have it as a fraction, what it means is for you to reverse the fraction, that this one will go up and this one will come down. Just like in this example I have given you now, this is 4. 4 and 4 over 1 is the same thing. I hope you know that. 4 over 1 and 4 are the same thing. So when you now have minus 3 as a power, so what we just did now to get that answer by saying 1 over, this 1 will be going up now. So we now have it as removing this minus will not mean that 1 will go up and 4 will come down. That's kind of reversing the fraction. Now from here, you'll be able to get the same answer as we got it previously. Now, the same thing is what we're going to apply here. Just take note of this negative power as a reversal of this fraction. That's to interchange between the position of the numbers we have on numerator and denominator. Then 3 goes up and 2 comes down once you remove this minus. So it simply means 3 over 2. That means reverse of that particular number, of which when you say raised to power 1, it's still the same thing as 3 over 2. Or you write your answer as one whole number, 1 over 2. That's changing it to mixed fraction. I hope this is quite clear. Please don't forget to click on the subscribe button. Share this video with your friends. Click on the subscribe button so they'll be able to get other interesting videos that we'll be posting going forward. All right, so let's now move to number 7. Then for the number 7 example, recall what we did in this particular one, that this minus will reverse the position of the fraction. That's exactly what we're going to do here in order to eliminate this minus. And by so doing, eliminating this negative power, that will now give us 81 going up and 16 coming down, all to the power 3 over 4. That will present us something like this. That is root law, of which the one on top means power, the one below means what? Root. So how do we arrange this? That will now look like this. That will be fourth root is what we're talking about here, because what we have on the denominator is 4. That's going to be fourth root of 81 over 16 all to the power 3. All right, so that's exactly how to arrange this. So the fourth root means what number do you multiply to itself 4 times to give us 81? And that number is 3. Because if you say 3 multiplied by 3 multiplied by 3 multiplied by 3, that will give us 81. And how many are there? 1, 2, 3, 4. So the fourth root of 81 is 3, because 3 is the number that multiplies itself into 4 times to give us 81. All right, so we do the same thing with the other one. So what number multiplies itself 4 times to give you 16? Of course, that number is 2. So we now say to the power 3. That will now give us 3 to the power 3. That means this particular power affects everything inside the bracket, just like we did in number 4 example. So that will now be 2. This 2 is affected by the power there, 3. So the final answer to this, 3 raised to the power 3 will give us 27 over, this will give us what? 8. And that is the final answer to this question. I hope this is clear enough. All right, so that is the solution to number 7. Then the final example, you can give it a try. You can give it a try. This particular one and this look quite the same, only that we have to do some technical work here in order for us to be able to make it look like a fraction. Now let's take number 8. For the number 8 question, the first thing we do is to express this decimal number in the form of a fraction. How do we do that? Identify this point as 1, then call every other thing that follows is what? Zeros. So from here, it will now look like 27 over 1000. That is how we do this for the elementary class. All right, so that will now be 27 over 1000 all to the power 2 over 3. This and this particular one are the same, of which if you punch this in your calculator, 27 divided by 1000, that will give you the same thing as this. All right, so the next thing we're going to do, when you look at this, means that we are talking about the root law once again, of which 3 represent the roots, and the one you have on numerator 2 represent the power. So recall how we treated this particular one. That will now be the cube root, because what we have here is 3, cube root of 27 over 1000 all to the power 2 that we have here. So what number do you multiply to itself 3 times to give us 27? And that number is 3. Because 3 times 3 times 3 will give us 27 over. Then what number do you multiply to itself 3 times to give us 1000? That number is 10. So therefore the cube root of 27 is 3. The cube root of 1000 is 10, all to the power 2. And that means 3 to the power 2 over 10 to the power 2. So 3 to the power 2 is 9 over 100. That is for 10 raised to power 2. So this is exactly how to resolve these kind of questions. Thank you for listening, and please don't forget to click on the subscribe button as we continue to post more videos that will make you to understand mathematics even more. Thank you.